The chunk that answers your user's question is sitting in your vector database right now. It is indexed, it's embedded, it's retrievable. And your RAG pipeline walked right past it and made something up instead. Here's the uncomfortable part. You probably blamed the model. You tweaked the prompt, you swapped GPT for Claude, you cranked the temperature down. None of it worked because the bug was never in generation. It was in retrieval. And retrieval fails way more often than you think. Here's a RAG pipeline everyone draws on the whiteboard. Query comes in, you embed it, you pull the top matches from your vector store, and then you stuff those into the prompt. The model reads them. Out comes a grounded answer. Clean, four boxes. What could go wrong, right? This is the mental model. Now, here's what actually happens in production. Studies auditing real RAG systems put the majority of failures inside retrieval and not generation. The model isn't lying to you, it's answering faithfully from the wrong context. So let's open up that one box and see the 5 ways it breaks. Failure 1. Your chunking strategy is destroying answers before they are ever indexed. Most pipelines split documents into fixed windows, that is 512 tokens, hard cut, maybe a little overlap. That boundary doesn't care about meaning, it'll slice a sentence clean in half. So the setup for an answer lands in chunk 4 and the payoff lands in chunk 5. Now, neither chunk fully answers the query, so neither one scores high enough to get retrieved. The information exists, it's just been scattered across a boundary your retriever cannot cross. Fixed size chunking optimizes for tidy code and not for retrievable meaning. Semantic chunking, larger overlaps, or parent document retrieval put the whole thought back together. Failure 2 is subtler and it trips up almost everyone. The query and the answer don't look alike. Your user types a short question. Let's say, how do I rotate API keys? The document says credential rotation is configured under the auth block in the settings. Same meaning, almost no shared words. Embeddings are trained on similarity, and a terse question just doesn't sit near a declarative document. You're searching for the answer using the shape of the question, and those shapes don't match. This is the query document gap, and it silently tanks your recall. The fix slips the problem. Generate a fake answer to the question first, then embed that. That's HYDE, HYDE. Search with hypothetical document because answers live near answers. Query rewriting and multi-query do the same thing. Close the gap before you ever hit the index. Failure 3. Pure vector search is blind to the exact tokens that matter most. Embeddings are great at concepts and terrible at literals. Ask about error code 4021 and the embedding has basically no neighborhood for it. Product SKUs, function names, version numbers, rare acronyms that are dense retrieval smears them all together. It knows error code is nearby topically, but it can't pin the exact one you asked for. This is where the old school keyword search you thought you retired quietly wins. BM25 matches literal tokens exactly, that is the SKU, the code, the name, no embeddings are required. So you run both, dense for meaning, sparse for exactness, and fuse the rankings. That's hybrid search and it's the single highest leverage fix on this list. Failure 4. Similar is not the same as relevant, and top K makes it worse. Cosine similarity rewards chunks that sound like your query, not chunks that answers it. A paragraph packed with your keywords can rank first and contain zero actual answer. Meanwhile, the chunk that actually resolves the question sits quietly at rank 8. And what did you set? Top k equals 5. So you just truncated the answer right out of the context. Cranking k isn't free. So now you're drowning the model in noise. So you retrieve wide, then you re-rank narrow. Your embedding model is a bi-encoder that is fast, cheap, and a little dumb about relevance. A cross-encoder re-ranker reads the query and each chunk together and actually scores a match. Pull 50 candidates cheaply, re-rank to the true top 5 and watch the right chunk climb. Failure 5 happens after retrieval succeeds and it's the cruelest one. Say you finally retrieve the perfect chunk, you did everything right. You paste it into the position 6 of the 10 chunk context and call it a day. But transformers don't read context evenly. They attend hard to the start and the end. Anything buried in the middle gets skimmed and your goal chunk is sitting dead center. Retrieved, present, ignored. The answer was in the prompt and the model still missed it. So the order matters. Put your highest ranked chunks at the top and the bottom and not in the middle. Okay, so 5 failure modes. Now, how do you know which one is biting you right now? There's one move that cuts through all the guessing, that is log your retrieved chunks. Before the model generates anything, dump the exact chunks you handed it. Now ask one binary question. Is the correct chunk anywhere in that set? If it's missing, stop touching the prompt. This is the retrieval problem, so that's a full stop. Bad chunking, the query gap, dense blind spots, or a top K that's too tight. But if the right chunk is there and the answer is still wrong, now it's a generation or ordering problem. That single log line tells you which half of the pipeline to actually fix. Most teams skip this and spend a week tuning the wrong component. So here's the whole retrieval stack assembled, the version that actually holds up. It starts before retrieval, rewrite or expand the query to close the question answer gap. Then retrieve hybrid, that is dense for meaning and sparse for literals fused together. Pull wide here, 50 candidates and not 5. Recall first and precision later. Rerank with a cross encoder to find the chunks that truly answer the query. Order the survivors so your best evidence sits at the edges of the context and not in the middle. Only now does the model generate, and now it's finally grounded in the right context. That's the money shot. Every failure mode has a matching stage that diffuses it. Query gap dies at rewrite, blind spot die at hybrid, and truncation dies at rerank. Lost in the middle dies at ordering, chunking you fix upstream at index time. None of this is exotic. It's four stages most pipelines just skip. Add them and the model stops lying because you finally stopped feeding it garbage. If this reframed how you think about your own rack stack, do me a quick favor, hit like and subscribe if you want more deep dives like this one. Go check your retrieval logs. I think you'll be surprised what's actually in there. Thank you.